Okay. Our agenda today is a very busy one. First, we'll have community announcements. I want to thank Brian Thomas, if you're here, for editing the last three videos for us. And this is going to change the workflow a little bit too, and it might introduce a delay because he has a slow connection at home and I do too. But what it means at the moment is we'll be replacing, actually deleting and then uploading 3 new YouTube videos for the last 3 YouTube live forums. But going forward, we will just post the edited version from him. So we're just trying to cut out the noise and then anything that's a little bit not G-rated. So it might actually speed things up just to have this help. Other announcements just around the Proptool briefly, and we're going to talk about the Johnny Mac plans for holiday, Cluso's Retroblade, the Propeller accessory kit, some new objects. So those are just my announcements. We'll move through them fast, and we're going to move to 2 things of importance, 3 actually. The first being WX module from Michael. So we should be there in like 5 or 8 minutes. How to wirelessly program where to find stuff. Then we'll do a commercial break and I'll be showing off some of Johnny Mac's code. And then on to Steven's HUB75 update, and then Brian's single step debugging. So briefly, these are all the new objects posted, and they are from Surprise Johnny Mac. And John, run through what they are quickly.
The AT24C32, many will recognize that part number. It's an EEPROM. So this is just a very simple read and write layer on top of I2C for that EEPROM. The reason for that is for Ken and my friend Casey and anybody else who gets a kit, you know, and I don't know if you get, see my green screen's gonna be messed. So you can see my Johnny Mac is heavily populated with the RTC, and this module that's an RTC has that EEPROM on it. And then, you know, so we're using that so that we can add time to the project. And also, until we have a file system object for the flash chip, then it's really tricky to save parameters right now, because flash is not easy to use, where EEPROM is dirt easy. So when I wanted to add the timing to the project, I found that clock module, and it has an EEPROM on it for free on the same bus. So that's where that is. The DS3231 is the EEPROM, the RTC on that module. I2C devices is actually a little application that uses I2C, and it scans all of the legal I2C addresses on your bus to tell you what it finds. The NEC modules are receive and transmit of the standard NEC protocol. I had this what I do with it? It's on my desk. It's hidden somewhere in the mess. You know, I got this little $2 NEC remote from Amazon, and so I wrote a decoder, a decoder for it, and then I thought, well, if somebody has NEC devices, then you know the transmitter would be really easy. So to Greg, you might want to look at those two. The NEC RX has assembly in it, but it's pretty well commented and it's really straightforward, so that might be helpful. The TX may not be as helpful because it's 100% spin. And then as Ken pointed out, the Pixy2, that was I looked up at my the bookshelf over there and saw the Pixy module and thought, well, I wonder how long it would take me to convert that from P1 to P2. It took about an hour, and then Ken confirmed that it works, and he's going to show it off today. So that's what that is.
Yeah. Wonderful work, John. And the object, I was even able to use it. So it says a lot. We're going to use those too next week. So we'll talk more about that in a minute. Also, this is 2 purposes to this screen you're looking at. The first is to thank forum members, everybody here, for helping through new users who are inevitably are having trouble at the moment. And I was one of them last night. And I started out with Prop 2.4, and I got a very cryptic error about memory. And then Johnny Mac, he's one of those people I can ring up at night, thankfully. And he walked me through what to do. And what I did basically is what you've all been doing is I installed 2.4, which has an installer, and then creates the libraries for you. And then I went and got the 2.3 exe, and then I dragged it into the 2.4 folder. And then I ran the 2.3 version, the alpha version, and everything worked. So I post this here to say thank you and what a mess it is, and we're trying to clean it. So then first thing this morning, I called Jeff and woke him up, and he found the problem. The problem with the memory issue is there was a difference between the compiler he had and what Chip was using in Peanut. And he says that he might be able to fix this by 4 o'clock today. And this was going to be a kind of a private small group, and then I got so excited I opened to the world, and then I made a kit right away, and the kit looks like this, and here it is, and they got posted today, and surprise, surprise, the very first one shipped to Roy Eltham. There were only 12 of them. I know, can you believe it? Surprise, surprise. So Roy got the first one, and then the last one went to Mike.
I got the email and I went to the store. There's nothing special about that.
Thanks for keeping us in business. So there were only 12 of them today, but tomorrow there will be many more. And this guy's bagging them up right now. It's Mark. And he's wonderful to work with. He's just saying here, get out of my way. So there was the first slot. Roy's is in the lower left. Mine is in the right. Mike Green's is in the middle.
If he's been doing the new kits lately, he actually does a pretty good job of packaging stuff.
Yeah, he does. And this kit has just, I got to say, a lot of cool stuff in it. It's fun. Get one. And we're going to make this a permanent thing anyway, this kit. So it looks temporary, but I'm going to renew it. And then it was so exciting to find this in the post. This is just beautiful hardware from Ray. And it looks so good. And I have 2 of them. One has flash and one doesn't. And Chip's getting the one with flash. And I'm going to photograph them first before they go to you, Chip. So anybody that's
where did Clouseau put the flash on the back or something?
Yes.
Oh,
He did.
And we can look at that later under the document cam if you'd like, that I have set up today.
That's good. I love VGA.
Yeah. Yeah, this is simple.
Yeah.
I mean,
apparently you can solder it comes loose and you can solder it on optionally.
for 50 bucks, it's a great set of hardware.
Okay.
Ray needs to ship some more over here so I can ship them out.
Yeah, whatever system you guys have is nice, and keeping us out of the way keeps the cost down and achieves the goal.
By the way, I hate to interrupt, but Johnny Mac mentioning I think it was Johnny Mac mentioning the flash on the P2. Some time ago, I added a version of Femto Basic that used flash memory instead of an SD card, and it should be in the forum. I don't know offhand what, but the code is easily convertible for Spin 2. And I'd be happy to do that and post it if people think it would be useful.
I didn't know that, Mike. So thank you for telling me, because I would like just to have for the time being, similar. You and I have both written basic I2C drivers and EEPROM, objects on top of that. It would be nice to have something similar for the flash, especially since we have so much of it on the board.
Yeah, and it does set up a file system, so you can have named files.
Oh, nice. Okay.
Main thing
Thank
it
you.
doesn't do, you can start a loader on the P1, and that's the biggest piece that isn't converted over.
Okay. But we have code from the Spin compiler, and I think Ray Roddick too. He has code that he's posted for loading files, right, Ray? I think you've done that for the flash. So there's source information there. We should be able to, maybe that's something you and I can work on together, Mike, because I think it would be nice to have a little generic file system, even if it was slowish in Spin 2. Would be a nice way to save data for applications like my little Christmas light controller.
Yeah. All right, I'll send you an email.
Okay.
Great.
You should maybe check with that team Oz, because they have in Python already a running file system, and we might consider to use the same file structure as they use in Python.
Yeah, I was going to do that. I have a copy of Clouseau's OS, and I was going to just write some utilities to sort of copy stuff from an SD card onto a flash Anyway, Johnny and I can
Great.
talk about that, and we'll come up with something.
Thank you, gentlemen. And if anyone's waiting on the P2 accessory kits, those are back in stock. We're running very late on producing things these days, and it actually reaches way back to the beginning of the pandemic when everyone was gone, and now we're really paying the price. But prop plugs are going to be the next thing to go out. So if anyone tries to get a bundle, those prop plugs will not be replenished until January, mid-January. And this brings us to Michael, and this is good timing because we just finished building 350 Wi-Fi modules, and this is one of Michael's designs, and he's going to show us where the resources are for this and probably demo. And we wanted to get to him first because he's staying up very late for us. Thanks, Michael.
Unmuting's always helpful, isn't it, at this stage? Yeah, you're welcome. I'm usually rattling around this time of night. Actually, someone asked me this morning when I answered some support emails at, I think, 6 o'clock a.m. my time, asking what the hell I was doing still up, thinking I was in the States. And of course, now it's kind of, you know, midnight my time, so it's been a long day. It's been a chip day.
Yeah,
So,
first thing when I call Chip is I say, are you getting up or going to bed? And the question's the same, regardless of the 24 hours of the day.
Yeah. Okay, so shall I go ahead and share?
Yes, certainly.
Here we go. So you should see the Parallax website, all being well. Okay, so this is going to be a quick step through of how to use the Wi-Fi module for wireless programming. A few people have asked how to set things up. What we need to look at first, I guess, is the hardware. So the things you need are the Parallax Wi-Fi module and the Wi-Fi adapter plugged into any suitable Parallax breakout board. This is just using the mini breakout board, but it'll work just as well with the Johnny Mac Edge or the eval board. And that's it. That's all I've got going on. I've got this powered by a 5-volt supply. I've plugged in a monitor just so you can see something going on, and I've slapped an LED on there for the same purpose. But for the programming, you just need obviously the Edge module, breakout board, and the Wi-Fi adapter board and the Wi-Fi module. So the first thing you need to do is update the firmware if you've got an existing SIP wireless module. The wireless modules Ken just showed, which are being built, well, which were built today and yesterday, they're going to be programmed with the new version of the firmware code. So if you're ordering a module in a couple of days' time, it will have the firmware built in. But if not, then you just need to update the firmware. So I'll share a link, I guess, in the chat window. Okay, which I can't get to during the meeting, but I'll share a link in the chat window at the end of the meeting to this public folder, which has the latest firmware in. That'll also be pushed to the Parallax website in a day or two anyway. What you need to do is get to the Parallax Wi-Fi modules configuration screen. Now, I did want to show you that, but then I found out when I've got Zoom running, I can't also have a second network running. So we just have to assume that you know how to get to your Wi-Fi modules configuration screen. If you don't know, you can ask on the forums for help, or in the folder that I'm going to share, I've made a little document there, text document, how to join Wi-Fi network. And there's just a link in there which takes you to a Parallax tutorial which shows you the steps. But if you don't know how to join your module to a network, usually the way to do it is to grab a tablet or a mobile phone, switch on the Wi-Fi module, hunt for the Wi-Fi service, connect to it, and just browse to this IP 192.168.4.1, and that will then bring up the Wi-Fi configuration screen. As I say, you can ask on the forums for help if there's any questions about that. So we now get to the Wi-Fi module. So I've joined the local network here, and this happens to be the IP address. So the things that you need to do, first of all, go to the firmware if you're running an old version, and just choose File, open the update file, and update. And it's as easy as that. And the process is pretty quick, 2 or 3 seconds. It'll tell you when it's done, start rebooting. And any minute now, we're done. So the firmware is now updated, and you can go to the home page just to check that you've got the latest version, which was built an hour ago. The next thing you need to do is go to the settings page. And here, there's a couple of things to change for P2. We want to enable the P2 drag drop loader, which is down the bottom here, if you choose to program your P2 this way. We'll save that. And you also want to change the reset pin to CTS, because the wireless module using the SIP adapter is using CTS for reset. So we'll just save that. You can optionally change the baud rates as well. In fact, I'm going to do that. Why not? Let's go up to 2 meg baud. And we'll just save those. And also I'm going to save to flash. That would save it permanently after a reboot. If you're going to use this same Wi-Fi module for programming P1 things, then you might want to consider leaving the loader baud rate at 112,500, because that's 115,200, because that's what the P1 uses. But anyway, you've got the option to speed things up for the P2 if you want to. And that's it. The main thing is to change the reset pin to use CTS. So we've done that, we've saved to flash, and you'll notice on the left here, a new menu appears called the P2 drag drop loader. So just click on there, and there's a couple of tips at the top, or reminders, just to remind you that if you're using a Wi-Fi module that's got the dip switch settings on it, which is the P2 eval board or the edge module, it just reminds you which dip switch to have on or off. And yeah, and again, a reminder to set the CTS pin. But yeah, so here we are. Yeah, so really it's just a question of dragging and dropping in there, and you can see the LED blinks. Let's just get that over to the other side. So it's pretty quick. And if we go for the spiral demo, which is a bit more interesting, take a little bit longer to upload, but there we go.
It's so fast.
Yeah. Yeah, I mean, if you remember the trouble Jeff had to go to speed up the P1 loader back in the day. And now it's just not needed. This thing just streams straight in.
Can you do it again where we can see like how long it takes from when you hit go to when it shows up? Oh, you know what? The longest thing in this loop is the HDMI screen waking up and beginning to show.
Yeah, I mean, I just dumped in the toggle 8 binary. I'll just do it again so you can see that one load in.
Oh, so it's a split second.
Yeah, so that's now cleared the screen essentially. So now I'll grab the other one now. Here we go, P0 binary. Right, think. Yeah, so that's done. So that's now, so the P2 is confirmed when it says done at the bottom of the screen. It's pretty quick. It's almost not worth having a progress bar, but.
Oh, let me see again. I want to see the done progress thing. Drop that file again. I wasn't looking at that part of the screen. Whoa. Yeah, it's like a quarter second or something.
Yeah, let me see the size of that. Oh, okay, so that's a 1 kilobyte file. Yeah, I haven't got a full-size binary here, unfortunately, to try. That would have been a good idea for timing it, but we can do that another time. But yeah, it's very quick. Well, it's running at 2 meg as well, 2 mega board, which is nice.
So that's on the wireless modular side to the P2.
Yeah.
Michael, as a recap then, the process was power up the module, connect to it by going to its IP address, then configure it, right?
Yeah.
And then it's connected to programming pins on the P2.
Yeah, I mean, it's just plugged in with this header adapter, which just plugs onto any of the development boards that have got the programming pin with that RES graphic on it, the white square graphic that says RES. So it's compatible with the Johnny Mac as well. It's got the same graphic up there.
And so you connected that device to your wireless access point, and then you're still on the wireless access point, so you could browse the net and program this device.
Yeah, for this Zoom thing, it all fell apart when I tried connecting to it locally, unfortunately. But yeah, it's on the same net at the moment. You can do it either way usually. If you're not on Zoom, you can connect to it directly as well.
Now, if somebody
I'm sorry.
Yeah, no, go ahead, John. I wanted to ask about accessing this from somewhere other than directly connected to the wireless access point when you're done.
Well, I think we probably had the same question. You know, let's say I'm out on set somewhere and I don't have wireless. I can go direct from my PC to the device, right? Wireless.
Yeah.
Perfect.
Yes, that's true.
Excellent. Yeah, that's excellent.
It's just when you do that, you'll also not have access to the internet.
Yeah, but I don't anyway out in those locations. That's what I'm saying.
Sure. Yeah.
I just have to tell my PC, use this access point and point to the propeller.
Yeah.
Right.
Yeah, and it's just the same process as connecting to any other access point whilst you're roaming around. You just connect to this one. Yeah.
Got it. Perfect. Well done, Michael. And Jeff.
Oh, Michael did most of this.
Would it work the same way?
My work was done a long time ago.
Yeah, and there's one other thing to note as well. With as I say, this new firmware version will be in the new Parallax modules that will be shipping out shortly. Ken showed them in manufacturing just earlier. This firmware now includes a few other updates that the community have shared through the forums. One of them is hide loader, so that it ships default no, but you've got the option to switch it on if you don't want people to be able to find your access point, as John just mentioned. Let's say you're on site working with wireless and you really don't want all your colleagues connecting to your access point and getting up to no good, then that option is there. And I think there was some UDP communication updates added as well. So now it's UDP capable as well as TCP. Those updates are included too. So I think there was a third thing, I just can't recall what it was.
I think there was a bug fix because maybe you'll remember seeing this, Michael. There's a feature where people can drop files onto it for like what I was talking about earlier that Andy Lindsay did, like HTML, CSS, and JavaScript files that it will serve for you, but it would allow you to keep dropping more and more files until it overran its user file space and actually kind of bricked the module. And so you'd have to do a wired update to the firmware. I think that fix was included.
Yeah, that's included. And actually the firmware's been extended now to use the whole 4 megabyte of flash rather than just being restricted to 2 megabyte, which the original release was. So that can help with that as well, I guess. Yeah, you have more free flash memory.
Ken, was your question answered?
I think so, yeah. How would somebody access this remotely? And they would just need an IP address to type in? Is that correct?
Yeah.
And
well,
then your router would have to accept me.
Yeah, you're talking about setting it up so that it shows up on the net and it's accessible from a really remote location, for example, right?
Somewhere other than Michael's living room.
Yeah, so what you'd have to do is the router that it's connected, the router on the subnet that it's connected to would have to be one that you can configure to support port forwarding.
Mm-hmm.
And then you come up with a port number. and you know, configure the router for that. And then from whatever location you're at, you use the IP address of your internet side of your router plus that port number. And
Wow.
And then it goes through. It's a little complicated.
So
I know how it works. I haven't tried it myself with the Wi-Fi module.
teachers have been asking if we could set up a camera at Parallax with robots in the middle that students can program during this pandemic.
That would be how you'd have to do it.
Yeah.
You have to do
Well, maybe next time, Ken, I'll
Yeah,
I'll
that's
set,
a big-
I'll set up
big
I'll set up
request.
NAT forwarding for you so you can control my module from there.
It's really fun. I'm thinking about what we might do with this.
Yeah, scary.
Yeah, and you'd
No.
want to do it. I mean, ideally, you'd want to use some, you know, Wi-Fi device or subnet that is not connected to anything else critical.
And yeah,
I think I'll probably lock it to Parallax's IP address range anyway, just to be safe if we're doing it over a live PT forum. But
correct.
yeah.
We already-
Michael, you showed it connecting from a phone like Johnny Mike was suggesting. Can it connect to a hotspot? If I set my phone up, would it connect that way as well?
Yeah.
I can answer that too. He's right, yes, but I have seen some phones that where it will connect, but you won't be able to access it. And I think it's because some phones and also some routers automatically do client isolation to keep people from hacking each other on the same Wi-Fi access point.
Mhm.
And if that feature is turned on, then you won't actually be able to use it over your phone's hotspot. I mean, you know, if I'm assuming you mean you have your phone that's acting like a hotspot, you have your Wi-Fi module associated to it, and your PC. But the two won't be able to see each other if there is, you know, client isolation happening within the hotspot. Did that answer your question?
Just say hypothetically, I'm in the middle of Yellowstone and I've got 6 of these Johnny Mac boards with Wi-Fi hooked, and I set them up as perimeter sensors. Would they all be able to hook to one phone and wake me up in time before I die?
Yeah.
Getting ready for the apocalypse.
I would definitely test it
I
before I
couldn't
put
think of
my
nothing
life
else.
on it. Like I said, I found, I think Ken's iPhone at the time that I tested worked just fine doing that. And the Samsung phone that I had did not. And I later theorized, but I never proved, that my Samsung phone was doing some kind of isolation. Because I've seen the same thing happen on real Wi-Fi access points where isolate, like if you go to a Starbucks, hopefully they're all set up so that they isolate, they give people access to the internet through their access point, but they don't give people access to everybody else that's sitting there also.
To each other, yeah.
Yeah.
Which means they're not offering name services registration and sharing between the local devices.
Well, I mean, even if they're on the same subnet, usually you can ping each other.
That's the ICMP traffic likely blocked. That's a default security thing, right? So even pings won't work in that case. And if I use, for instance, Google Home, all my devices are blocked from each other unless I specifically open ports.
Okay.
I have Wi-Fi on my iPhone. It's a mobile hotspot that can take up to 5 users, but I never had a user that I didn't give the password to hijack it. Well, that I know of.
Yeah.
Stop, which you can all see now, right? And what I'm showing today, great. This is actually some code Johnny Mac wrote, and it's for the Pixy2 camera, which is 4th or 5th generation. It's a camera that can recognize locations, colors, sizes of objects in front of it. And the way the camera works is you hook it up to a PC and you train it on the objects, and you associate color signatures with those objects. And then with this code, you can run it and see the position of the objects in the view of the camera. So I'll show you the demo of that. Let me also find a serial terminal. Okay, so what I have here, and I'll scooch back, is a document camera and a Johnny Mac and an Edge. And that's the Pixy2 there, just looking forward at these colored cylinders, which are from Carol Hazlitt. And we'll just start by cleaning up the view here a little bit. And you can see that I associated the blue one. It needs to be in the view there. Okay, so it sees 1, sometimes 2 signatures of 3. And what it's probably doing is seeing the top and the bottom half of the block. I trained this when it was dark yesterday, but based on the lighting, for example, if I turn off one of the lights here, it'll probably fix itself. Let me do that. Yeah, sure enough, right? And as I move that around, you'll see the X position, which on the far left goes down to 0, and I think that's identifying the middle of it. And on the far right, it goes up to, is it 300, John? Yeah.
And I'm sorry to interrupt. I was just curious if that actually could tell the difference between the color of the human eye and then the white part.
Between the white and the
Colored
blue?
portion of the human eye.
Oh, I think if you're close enough, it could. My experience with it is pretty good in that way. I haven't tried it though. I think it might have a focus issue up that close though, but maybe you can put a lens on it.
Okay, thank you.
But Ken, this is based on a 2-dimensional camera, right? Not. So
I
it's
don't
getting
know.
some kind of video image that it's processing, or is it some kind of.
It is, and obviously we'd like to see the Propeller doing the video image processing, but this is just a 19.2 UART to the Propeller.
Ken, remember too, with the P2, you can run as fast from a serial connection to the Pixy as you want because we're using smart pins. The 19 point was a limitation of doing bit bang serial on the P1 because we were trying to conserve cogs. But the P2 uses smart pins, so you can do as fast as you want. The other thing that you can do for those that are interested, you can plug a USB connection into the Pixy Cam and plug that into your computer, and then just use the serial and ground connections to the P2. That way you can see what the Pixy is seeing, and then you can see the data coming from the P2. And that's a good way to kind of learn and understand what's happening with it. Because it'll not only do single color blocks like this, but it has the ability, if you have 2 colors that are touching each other, it will identify that as a block, and it outputs an octal value that tells you the configuration of colors within that block.
So actually that, just to make this a little bit easier to follow, yellow signature 1. What do you guys think of that? Pretty neat, isn't it?
Quite fun.
I think
Yeah.
that's pretty impressive.
I think it has ALS applications actually.
Ken,
Hi, Carol.
if I printed up the right kind of rings in different colors, could you do a Towers of Hanoi with it?
I'd try. Yeah.
Talk to Erico on that.
I don't. He always beats me in everything.
So a lot of fun with this, and really easy to use object from John, and encourage you to take a look.
Get the impression Erko's too busy for anything right now with his solo venturing.
Yes, indeed.
I got a question.
Michael? Yep.
So how do you train it? What is the training?
I could show you their software, which is called Pixymon. And you can also train it with a button. So let me open the software, then I'll share the screen again. bring y'all back.
The Pixie Cam has the ability to look at a spot on the screen and tell you what the raw color is. So if you were doing an application where you wanted to, like an M&M sorter, where you wanted to put the brown M&M underneath and then train it manually, you could do that.
My mount for the camera is kind of falling apart, but I think you get the idea. So the process goes like this. First, I'll just clear all the signatures that it has in memory, and then go into your configuration, and all you have to change for John's code is to use data out as a UART. The default is something called an Arduino, I don't know, and then do 19.2 as a baud rate. Click apply, and then you can train signatures. So for everything in front of it now, I could just basically set a signature and then identify what that signature is. So red will be 1, and yellow is going to be 2. And then I'll make the blue 3. And then if I add in another blue, it'll see it. Or another yellow. And Carol
And that
also.
camera is like, is that 320 by 240?
Yes.
Nice. Yeah, that, you know, well, so you take 24 bits.
So now we've added that in.
It must be
Yeah.
doing some sort of averaging or something on the colors.
It does.
Yeah, I think you're getting, you can see the refresh of whatever lighting you have, some flickering. So if you had more consistent lighting, you'd probably have even better results.
I'll turn the light off.
It's the fluorescent overhead lighting has
Okay.
60 hertz flicker.
I've turned all those off now. So now I'm just using the LED that's on the Pixy2, and you can toggle that on and off as well. However you train the camera, though, you need to make sure your code is doing the same thing.
Will it see the green one at all?
Yeah, I'll add it.
You could train it.
I lost
It would
count.
also be, it'd be a little helpful with flat surfaces. Because with a rounded surface, you have the natural fall off.
Right, that's what I was going to ask you. If like square objects is easier than the cylinders that you have here.
Flat surfaces facing the camera certainly are.
Cylinders are easier to print.
John, you made a comment. Is it possible to actually see the video that it's seeing?
That's
what this is.
Okay.
Yeah, so if you have, if Ken had a second connection, and which, you know, I did the other day when I was updating the code, I had one USB port into Piximon, and then the other one, you know, was going into the Propeller, and I was using it to debug. So you can see what it's seeing and then see what the output is.
And so now I'm getting kind of mediocre results too. And I'm not really sure why.
Well, this is...
you changed the lighting significantly, so
exactly.
So you probably have to retrain it.
It's my fault. I suggested that.
Well, it is a demo.
Well, this is, you know, when you do things like this, you find out how amazing the human eye is, because we can change lighting levels dramatically, and to us, we don't think there's as much of a change. But to an electronic device, it sees that right away.
One of the funny stories from Robothon, and you know, in Robothon, you have to find an orange cone. And this one particular year, the Seattle Center had painted a garage door that was across from the field a bright orange color. And all the robots went that way.
Very interesting.
Yeah, so you want a camera that'll also detect shape and size.
I have a question, Johnny Mac. There is some C library for the Pixy2 using USB, and that is also giving the video data. Is there any way to get that into the P2?
I don't know. I don't do that video nonsense. I'm just a digital guy, so you have to ask one of the video wizards.
Any other questions around this, or can I put it to sleep now?
I think, Michael, I know I was being smarmy. I hope I wasn't being offensive. I didn't mean to. I was being jokey. But Chip seemed to chime in. He was a little bit excited, and it looks like he's calculating in his head right this second when he found out what the resolution is. I think he immediately thought, oh, hey, I could probably write something for that.
Yeah, it's 240 kbytes, which is not much. That's at 3 bytes per pixel.
One last thing too, and on that, Chip, remember what I said, you don't have to use 19.2 kbaud because on the P2, we can go as fast as the PixieCam, which I think it's 230 kbaud is its fastest bit rate, which we obviously can support in a P2.
Oh yeah, I was thinking of just the fact that these little cameras exist that have these resolutions that you could read them straight into memory and you know, process the data directly.
You can also, it will, I believe there's a function in there. I haven't looked at the whole thing, but where you can ask the PixieCam what color is at this pixel location. So you do a quick scan, you know, where it's got the color array in its image, and you can find out where things are. So you would, but to your point, if you had the array inside the P2, you could do a lot of things really quickly.
Maybe Stephen, you want to share what you've got?
Sure, I can do that. Can I find my desktop? There it is. Okay, do you see my desktop?
Yep.
All right. Ken, I don't know how you're getting to the object exchange. I just have this old link at propellerparallax.com. How are you getting to it otherwise?
That way, or I'm going to Parallax Sync GitHub.
Okay.
So this works.
So in your list of changes to the OBEX, you missed one.
All right, great.
Because if you go to display, you now see the ISP HUB75 matrix driver. And so it's out here. These are the files for the driver.
I hear the crowd cheering.
Say again?
I hear the crowd cheering.
Oh, okay. Here we have the files for the driver, and we have a zip file, which is the demos. I'm kind of following John's pattern for doing this, where the demos are just in zip files, but then the basic files are elsewhere. I also speak to the fact that there's a whole bunch of documentation up in my repo, and that's right here. And there also will be a HUB75 driver board soon for sale at Parallax. Let's go to the repo, and under releases, you'll see the same file in a single zip file. Right here, anytime I release something to OBEX, I'll also have it here. So if you want to go for it, here are the limitations of the current release. Going back down, this is the top README at the repo. We have the link to the object exchange and the releases page that I just showed you. We also have a couple other things. This is what it originally looked like, the hardware terminal, but we also have driver details and how the thing works and how we're going to configure it. Current project status will always be here, what's working, what's not. Currently, this supports a single panel up to 64 by 32, that's width by height. After we get the boards released, then I'll go ahead and make sure that 64 by 64 is working well. And also, I'm jumping immediately from there into multi-panel support. When you get the driver, you'll want to look for this one file and change some defines in that file. And then when you build it, it will know where your panel is. And so you can see the adapter base pin, which pin group is your adapter connected to. If you're using like this special chip, tell it in the panel driver chip, and it'll use different signaling algorithm over the HUB75 adapter to do that. And then this describes panel columns and panel rows. Notice I said panel. As we get to multi-panel displays, then you'll additionally have display columns and display rows, which describes how it's set up. So then we can start thinking in terms of writing to the entire display, not to individual panels. With the driver comes 3 demos in the demo.zip file we mentioned. You have a demo color, a demo text, and a demo 7 segment. Let me then, since my room is not set up for Zoom cameras, I did a quick video. So let's look at that video real quick. Okay, here we're filming one of the demo color. Can you all hear the audio okay? Showing off the colors of the panel as the driver is currently working in the OBEX.
Yes.
There are 3 top-level files. This is the demo color file. It just shows a bunch of different color patterns. The demos are arranged for 64 by 32 panels, driving a single panel. Here you see the screens being blasted as 3-bit color and held with no PWM. That's why the amperage is so high on the meter in the background. And then when we get back to PWM, it's all low amperage again. Quarter amp to half amp. Below an amp, let's say. Now we're switching to the 7-segment demo. This is also one of the top 3 demo files. Here you just see a possible way to do some automation using the panel. It's a loop called routines, and the routines each indicate when they're done doing their thing. And so there's, take a look at the demo code, and it should be just an example of how you can do automation without running multiple threads or multiple cores. Of course, we can also do this with multiple cores, but this is just a quick demo for you to play with.
Is that the Adafruit panels?
And this one is a quick demo of just the different fonts and scrolling text. As you can see, again, using the same automation technique we used before, and therefore it's slower when there are multiple ones and faster when there are fewer scrolling buffers. In the end, the scrolling mechanism will allow you to place scrollers anywhere on the panel on any width, and they'll try and do the right thing in terms of scrolling text through the region that you said to scroll with the colors and the font that you choose. And that's the end of the demos. Okay, this is a quick tour of the workbench where we're developing the driver. You can see I have a lot of stuff around here. We're running a peanut at this point. Driving boards. And I've got a collection of matrix panels here. These are all 64 by 32 other toys for the eval board. And a P1, because you have to have them around. Well, that's Raspberry Pi for debug. That's just for the board, the plug board. Okay, so here we are with 2 of the boards. You've already seen these. These are the 1.2 boards. The 1.2 boards are red. The 1.3 boards are green. And we have a new member of the family shortly. This is what the boards look like when they're connected to multiple ports. I'm still driving single panels, but I'm getting ready to drive set 2 panels and test them out. And that'll get our whole chain working. And then here's a Johnny Mac board with a P2 Edge, and you can see the new 1.4 member of the family. And that is now driving this display. And then the noisemaker here, you get the background noise, that's our logic analyzer. We're cabled up right here to these guys. And I just pick which one I'm listening to at the time and capturing traces. And then a standard bench power supply, so I can tell what kind of amperage we're running. And it looks like it's fallen to 4.5 volts. Normally I keep that at 5. You never know when you leave equipment lying around. You haven't been at it for a couple of days. You need to come back and adjust it. Anyway, this is the display. Let's turn this down a little bit. Yeah, it's not letting me adjust it. Anyway, nice rich colors. This is 16 frame PWM. Where the frames are not ideally timed, we'll get back into that. They're just identically timed at this point. We'll probably do some more advanced techniques for doing better, richer color generation and also better intensity representation. You'd like to go from low to brights, not just bright to off. Yeah, so we're working on that as a driver. That's pretty much the bench. Just wanted to show you what we have going. Well, I also thought while I'm here, I might as well describe what I'm doing with the, how I'm setting up these boards. You see them all at an angle. What I did is I have 3D printed legs that I just pulled off of Thingiverse. I pulled the STLs down and then just printed them, and they have them for these different matrix panels. And so that's what I'm doing. Yeah, I print different colors. So you can see that I've got the green one on the panel set that's going to be a pair here. The cable's there and the power is ready to be plugged in. I just do have to do some driver reconfiguration before I can drive both. And that's the backside.
Wow. Let's get some questions for Stephen, unless he wants to.
I have a little bit more, but yes, let's take.
It's great. You show more. And while you're doing that, Stephen has volunteered to do the frame of a cube using panels that look like this one that we've ordered off AliExpress, the square ones. If somebody could rig up the internal power supply, suspended battery. So maybe we'll talk more about that too.
I'm not sure you meant me, but okay.
I think
the other one.
Me. I'm the other.
Jonathan, sorry.
Right. Yeah.
Jonathan Shook.
Thank you. Thank you.
Yeah.
I'm like, wait, what?
Without,
Okay, to finish the presentation then, I just have a couple more things. This is then how you hook up the board with the new display adapter. That's what the new display adapter looks like. They'll be orderable from Parallax. This is more project ideas where I'm going for. But the other thing I wanted to show you is a little bit more about the driver itself. Here are the different files. If you click that link to driver details, here are the different files, the purposes. You'll see some of them are core, some of them are optional. And this is where you, this right here is where you modify and specify your panel before you compile your panel geometry. When you're configuring the driver, it's a serial list, it's a serial chain of panels. HUB75 is a serial chain of panels. And so you connect your adapter to data in, the panels are then connected to each other. They are all powered with, in the 64 by 32 case, it's 4 amps per panel. So you have to think a pretty beefy power supply if you're doing multiple panels. And then you're going to, the panels are hooked up in parallel off the power and the data is a serial. In the case of the smaller 32s, I think Johnny Mac has a 32 square. The other ones I was just shipped was 64 by 64 square. You're again going to hook them up in serial, but we'll arrange them in different organizations, vertical column, horizontal row, or grid patterns. And so I have to figure out a way to describe that to the driver and then just automatically do the math once the panels are described to the driver for when you're locating what to display where. Then let's see here. These are again the configuration values you're going to change based on your configuration. And then when it comes to data flow, you write in 24-bit color to the display buffer. On the way to the display buffer, it's translated to PWM indexes, which is basically which colors are going to be displayed during which PWM phase to get the right color intensities. And then as you commit the buffer to the screen, it's split out into PWM buffers, which are then described as on or off for all 6 red, green, blue. So now it's a byte for every 2 pixels in the PWM panels, but it's PWM wide the number of buffers you're using. That then is streamed out to the panels over the HUB75 interface. What makes these panels unique is this HUB75 connector. And what you're doing is you're sending out 3 bits RGB 0, 3 bits RGB 1 as the colors. And typically, I find most often the top half of the panel is RGB 0, the bottom half of the panel is RGB 1. Then the second thing we find is the rows are addressed. In my case, I have 32 rows. In the 64 by 64, we have 64 rows. So you will find panels that use only addressing bits A, B, and C. You will also find panels that use A, B, C, and D like the 64 by 32s, or A, B, C, D, and E like the 64 by 64s. So the driver and the board are equipped to handle all 5 address lines. The data is sent out with clocking indicating that when to sample the data on the serial stream. all the panels in the serial chain are in one serial stream. So if I have 4 64-bit 64 column panels, I'm sending out 256 data per row and doing 32 rows. And the clocking is here. Output enable is when the panel is turned on. The latch is used after the last data bit of the row, the complete row, 256 bytes in the 4-panel case, is set. What's really fun is some of the chips require that latch 3 bits before the end of the data through the end of the data, which really interferes nicely if we were to try and use the streamer. So I'm doing everything high speed through just driving the pins directly at this point. We probably, for the simpler panels, will also have an alternate mode. When you tell me it's not the special chip, the driver will probably switch and you just use the streamers if we can coordinate 6 pins being driven by the streamers.
Stephen,
so
you know what?
Some sense of future.
You could probably do a smart pin to generate that strange signal with that, you know, inconvenient timing.
Okay.
Right? You could, there's a few ways to do it, but there's one output mode where you select, I think, the overall cycle time, and you select the on time, and you can control polarity. So
well, that's interesting because that says we could drive the latch pin and the 6 RGB pins directly from stream.
Well, you're streaming unique data onto the RG and B pins, but you have a timed signal that you have to put on that latch, right?
Yes. Okay.
So that could be, you know, I did that. If you look in the Flash programmer that's in the distribution that I put out, you can see, I mean, it takes so little code. You just have to figure out what you need. And then if you know the timing, you can watch it on a scope and you'll tune it that way. But you could issue that smart pin command immediately after you issue the streamer command, and it would delay, and then at the right time, it would create the pulse.
Okay, great. That sounds like a great idea. So I think we're open to playing with everything. The last thing is a pitch. Since this is in GitHub, if somebody is interested in bringing in new fonts, or if somebody is interested in adding new drawing techniques, new text manipulations, if you wanted to participate, you literally fork the repository, which means create a copy for yourself in your own collection repos. You make the changes, you commit it to your fork, and then you issue a pull request, and then I get to see the deltas, and then I incorporate it into the code. So should you wish to help and contribute parts of this driver and work on special areas, coordinate with me, and by all means, please, the faster we work on things together, or I do it on myself, the faster it arrives. So this is here so we can all work on it and keep improving it. And that's all I have.
Hey, Ken, can I interject for about 1 minute?
Absolutely.
Thank you, Stephen. So I'm volunteering to build or design and test basically a 3D design for a cube frame, including a subframe to hold PCB and battery assemblies, whatever. There are some missing pieces. This is, if it's not obvious, in reference to the 3D Cube project we were kind of alluding to, talking about before. It would be really great to have a kit together. So I'm just going to add something to the effort here. We still will be looking for somebody to manage essentially the battery side of it, you know, to take on, you know, the stewardship of putting that design together and testing it to make sure we can drive enough current and have enough runtime and just source the right parts from Parallax, so we don't have to throw yet another wish over on top of Ken and Chip's shoulders right now. So if anybody is interested in jumping in there, just please reach out to me, Twix on the forums, and I'll try to work with Stephen so we can all stay harmonious.
How many LEDs and what kind are they that you're going to be driving?
Well, the panels, so Stephen has a couple panels. I have a set for physical prototyping. They're 64 by 64 pixels. They're at 2 millimeter pitch. So
okay, these same ones.
They're twice the number of pixels as what Stephen just showed.
Uh-huh.
But they're smaller panels. So they're about 5-inch square by 5-inch square. I mean, they're 5-inch squares. So
I'm actually holding it up, Carol, if you want to see.
Oh, yeah, right.
That's
When he said 3D, I thought he meant the ones that are the great big tower of cubes because I'm working on one of those right now. You know, where it's a whole hologram looking type thing.
I'm thinking about just flat faces.
Flat faces, okay.
Yes, but 6 of them will take quite a bit of current. And
Yeah.
based on what Stephen said, I mean, the current draw could be pretty high, but we know that we can logically limit the levels that we send in software, so we can kind of proactively manage that a little bit. Those 64 by 64 panels can put out a ton of light, way more than you would want to be looking at directly in front of your. It's just they could be very bright. So we can probably keep the current draw down to a reasonable level if we want to limit that in software, but it's still going to be significant. Like if you want to make a lamp out of it or a nice table accessory, I mean, there's just all kinds of things you could do with it. Play with it, make it a kinetic, interactive kind of thing. But there are a few pieces. I'm going to be quick because we're on an agenda here. The physical design, the frame design, which I'm volunteering to do and iterate with contributors on. Steven's working on one of the harder parts, which is getting the drivers in place. That weird memory layout to work with the streamer is a little bit of a curve. We'll need someone to deal with the power subsystem, and then we'll need people to buy the parts and test it out and help us refine it a little bit.
Okay. I'll try to take a look into it because I'm also doing something else for Ken right now.
If I may add on the panels, you saw that we can drive with full white at full intensity. I can drive a panel to 3.8, almost 4 amps. When you're running PWM though, depending on you can figure you're running on quarter of the power required for the entire system. And so you got some freedom there. It all depends on what colors you're displaying in HUB, right? So yes, intensity is another control, probably after the PWM.
So Stephen, just one more question there. It would be nice to know if you brought the LEDs up to half intensity based on your PWM brightness controls, what you would expect amperage for 6 panels to be, because that'll be our power value for a power subsystem.
Okay, I'll put together a set of numbers for the 32 by 64. Then I'm moving directly to the 64 by 64s. And so I'll put a companion set of numbers up for those as well. And as I discover that stuff, I'll just keep running that stuff up on the technical side, the driver technical page on my site. And I'll let people know when there are updates.
If anybody needs any help with 3D printing, I volunteer.
It might be good for me to send you some STLs and do some test prints and fits when we have enough to play with.
Okay.
Thanks, Ken, for letting me interject.
Yeah, this is great, and I'm happy to assemble a kit and keep it totally affordable just for the other stuff that goes with it. But I think you can fit a mini Mac in here, plus the adapter from Stephen, and a decent sized LiPo battery. If these are the ones you end up using, and this is what you're thinking, right?
No, it is those, but if you look very closely on the back frame, you'll see some screws.
Yeah.
So the heads of the screws are 1.5 millimeter diameter. I'm not talking about the heat insets. You see the little tiny black screws on the frame? It's actually screwed through the PCB.
I do. Yes.
Yeah. If you take those off, you can actually screw that 2 millimeter thick panel directly to a face frame.
Mm-hmm.
So that's the direction I'm thinking right now.
Yeah, those are very small screws.
You replace the structural frame with the cube frame.
Exactly, but hopefully with a couple door latches and discrete ways to open it. Yeah.
You have to get in some way to screw them to the frame.
You might be able to use neodymium magnets on one of your panel sides so that you can
Good idea.
on and off without having to screw or unscrew that side.
Nice idea.
And what was the voltage? I missed that part.
My older panels so far I'm running with are 5 volts.
Okay, that's manageable. But LiPo batteries, though, you'll need a regulator, right? Because they're usually 3.7.
Yeah, you'd need to upconvert it for the driver circuitry, but I don't know, Stephen, how you feel about this, but I was able to do the logic at 3.5V against the HUB75 interface. I'm not sure that's what we want to do. We probably need to get some level converters in there.
Yeah, the my board does the level conversion up to 5, and it
So does mine.
Yep, it pulls the 5 off of the connector, the valve
Oh,
board.
sorry, what I was saying, Stephen, on this board that I have, it's
You're driving at 3.
I'm doing direct 3.3 volts, and I looked. There are these two kind of odd corner chips, and they're simple buffers. So I think that's so that they to take the logic up to 5 volts.
What I found is they do level shifting for the output connector from the input, but when I ran 3.3 volt from the eval board to the board, the timings were way off. And so I couldn't control the pixels at speed because I'm running at an 18 megahertz rate right now.
Yep.
And you just couldn't control them. So I'd have significant portions of panels just missing. I thought it was driver problems until I checked the level shifters in, and all of a sudden it wasn't driver problems. It was just me meeting threshold.
Oh, interesting. Maybe I just got lucky then, because I've only run the panel at like 1 kilohertz refresh.
Okay.
And this is the screw you're speaking of, right, Jonathan?
Correct. There's on that one, I think there are 12 total, and
that's right.
They are easy to lose. You need something to keep them in.
Yeah,
there are 2 in the corners, it looks like.
So yeah, if there on the panel, you can see the HUB75 in and out connectors. And so, Jonathan, we just get to play with what are the top and bottom and what are the 4 edges. I'm assuming you want the 4 edges to be treated as a single row, and then the top and bottom panels would be other locations on the screen, maybe before and after the row?
I don't know, honestly. I think we should talk about that a little bit off video, just to kind of strategize a little bit. Sure. I think there may be some ways that we can make it fun to program without someone having to do this mental gymnastics about positioning. But that's I'd like to talk about that before we kind of inundate everybody with it. So.
Sure, sounds good. I look forward to it.
I think we should even schedule another get together then with this in mind, so we could get through the details a little more.
I like the lighting. Your connector on the left just blended right in. Those are shrouded connectors, which has me looking.
Yeah, and these panels come with wonderful cables to connect them, and definitely they'll hold the current. Come with all this kind of stuff.
The power cables, yes. The data cables, I bought some cheapy 3 times the length cables, and those do not pass the signal well. So we're going to have to be careful about distance between panels when we go diagonally in rectangular arrays.
I think we could even drive 2 or 3 banks to get to 6. If we wanted to run the HUB75 driver on multiple cogs and just have multiple cogs deal with just a couple panels each.
You absolutely can, yes. Just to give you a sense of size.
Yeah, those are highly dense.
Yeah, are those P2 panels?
64 by 64.
Are they P2 or P3?
Yes.
Or
no, those are P2. Those are
okay,
P2.
so that means 2 millimeters centric to center on the LEDs, or edge to edge. And they make P1.25s now. If you really wanted to get crazy dense.
I would really like to try that. I think the 125s would be actually more appropriate for what we're doing in terms of physical sizing and unit costs to make it approachable by the average hobbyist. However, I haven't been able to find any in bulk yet.
Gotcha.
So if we do find a line on those, I would really be interested in considering those as a higher priority, because I think the interface is all going to be the same.
Now, if you think pH, you could almost have a small ottoman. Just saying, coffee tables.
Yeah.
Well, if you go with this panel, you'll be happy to know the supplier passed my test from AliExpress.
Oh yeah. What was the test?
Can they deliver as promised and things arrive unbroken?
That's a good test.
Yeah. Not only does it get there, but does it work when it gets there?
Right.
Yeah, they actually wrote my name in a fancy way on the box. I was impressed by that little touch.
When y'all get the cube made, is it going to have 6 sides or does it have a bottom?
I think it would ideally have 6 sides, but it doesn't. I mean, that's kind of a customization detail. I think if you wanted to have box faces and have an open side or a bottom foot, I just think that's a configuration option that we should consider.
Well, I was thinking if it wasn't going to have 6 sides, if it was going to have a bottom, then you could not put a battery in it and just run it wirelessly on a stand.
That might be a really good way to start. Like just do that as the first design.
You could also mount it on a corner of the cube, run all your power in through the corner.
You're going to have to spread the frames apart from each other to do that as well, correct?
Yeah. These are good ideas. I'll probably sketch some things up in the next couple of days and share some visuals just to get feedback.
I have a question from you guys because I haven't seen a project doing it yet. It's still on this subject, sort of. I want to interface a P2 with a ESP3 board. Has anybody tried that yet?
We have an object for it, actually.
Oh, you do?
Yeah.
Okay.
Someone can find that link. It was written by Riley, Robots Everywhere, and Matteo Bori.
ESP32?
32, help me out. There's 2 more numbers.
Yeah.
You said ESP3.
32.
I'm drawing.
There's also one in the past that was the ESP8266.
Correct.
Maybe that's the one we did.
But I think both, I think that object uses the AT command set, which will work for either.
Oh, well, that's easy. I know that already. Let me see what this one says it is.
Yeah, I'm experimenting with that stuff right now too, Carol.
Oh, good. Then I can write you.
I haven't made a lot of progress yet, but I'm experimenting.
Well, I've got all my hardware work done and I'm ready to wire it up and program it.
Now, the nice thing is, you know, between the ESP and the propeller, it's just a serial connection.
Yeah.
And which one's on the Wi-Fi module?
It's a ESP32 now, right?
It's the older one.
Oh, the 8266?
I'm pretty sure.
Yes, it's a 8266.
Okay, and I pasted a link to the library that goes with the ESP32 in the chat,
Okay.
Carol.
All right.
I don't think anyone's used it. A lot of people wanted it, and we went out and had someone make it who has experience with this part, and it's really just a serial interface. We didn't take advantage of the processing capabilities of it. It's just doing its job. So it's a basic implementation, I'd say.
Well, looking at the board, it's pretty much just a pass-through interface for different communications from the looks of the board.
But if you look at what Michael was showing us earlier, that interface that was on screen with the buttons and all that, that was being served by the ESP8266, right? So that's
Yes.
what's exciting is so maybe, you know, it's a little bit more expanded, is learning the JavaScript side of it, because I would love nothing more than to be able to control my propeller with my phone doing that same kind of thing. So having the ESP, whether it's an 8266, like, you know, like the ESP01s, the tiny ones, whatever, you know, but to create a nice UI. I mean, I don't know if it was Michael or Jeff or whomever, but that programming, that interface that Michael was showing us earlier is really nice, you know, and you know, that would be a great thing to have on a phone for configuring, you know, projects.
Well, I
Yeah,
hope to be able to run the whole thing from a phone. What it is, it's the robotic arm that I'm putting on top of an Arlo.
Well, right. So you need a bridge, but you know, it's the same thing. So I think, Ken, the trick, you know, with anytime any of us write objects, is coming up with a demonstration that shows people how to do something. You know, an object is useful, but much more so when you see how it works. And
with a video, yeah.
Yeah, well, yeah, let's do something real. I mean, there's 1,000 objects in the world, or libraries for other processors say, oh, look, here I can talk to this widget. Well, great, but I want to talk to that widget to run Carol's robot arm. Show me how to do that. Many people are not willing to go that far, sadly.
So I can speak on that just a little bit. That configuration interface that you speak of, I use that from my smartphone every time that I need to reassociate my Wi-Fi module with, you know, between my work office and my home office. And also Andy Lindsay wrote a number of little projects that use just HTML and some JavaScript that I think we have up on our Learn site. Maybe Ken knows where. There's probably a Learn tutorial where he was actually, you can basically point a browser like a browser from your phone to it, and it brings up its own little interface that he created with just HTML and maybe CSS. And then he was able to tap on little buttons on screen to control a robot through the Wi-Fi module.
See, that would be nice. I have a project where I'd like to be able to do configuration of certain aspects of my Propeller project without having to recode it. Especially with like these movie prop kind of things, it would be really nice if I could just walk up with my phone, connect to it, because you know, putting an ESP on the board doesn't cost a lot of money. And it would save a lot of time if you know, somebody on set says, hey, we need that to do this versus that. And it was something in a configuration. I think that would be a useful tool, because then that same kind of thing, and maybe what Andy has done is a place for some of us to start. But it sounds like, Carol, what Andy has done is something that you're looking to do with your robot arm.
Yeah, I'm just getting into the software of it right now. So I have to start doing my search for objects and other people's jobs they did on it and all that good stuff.
I just pasted a link to the example Jeff was speaking of in the chat. So check that out, Carol. Look, Stephen, thank you. This is awesome. Great work. Incredible documentation too. And by the way, the hardware, you mentioned that you're building them. We're going to sell them. They're $24.95. And we'll have 20 when you're done. So it looks like maybe a week to 2 weeks or so, but we're getting there. Well,
hey, Ken, can I say something before we switch to Oz Dev?
Proptool, we were talking about you before you showed up. Yes.
Yes. So as many of you probably know, there's a bug in the version 2.4 where it compiles certain code and complains about a memory overrun. That was something I really didn't know about until recently, and was kind of mystified what happened there. But Ken and I talked about it this morning. I decided to push things aside and work on that to get a patch out there, and I got it fixed. It was my fault, of course. I grabbed Chip's code and shoved it in there, and everything seemed to work, and I didn't notice that he had changed something that was in the compiler interface that I failed to adjust in my code. So
sorry, Jeff, I should have thought to say something. What was it anyway? Was it was it in that big data record that talks?
Yeah, it was a number of fields for the debug features.
Oh, yeah.
And so effectively my code was seeing data that it was misinterpreting as a memory overflow.
Okay.
So, but anyway, so there'll be a new version. I've already built it. I'm going to go test it now on a couple different systems, and probably hop off the meeting a little bit to just kind of think about it carefully and get that published. So a little later today, there'll be a version 2.4.1 that fixes that and a couple of other issues that people have noticed.
Jeff, does that allow for Chip's fancy debugging windows?
It doesn't yet. That's in the works, but I had to kind of step back and I didn't want to introduce that code in the state that it's in. So I went right back to version 2.1 and patched a couple of things.
We're happy with the small incremental releases too.
Yeah, Jeff, I've just made some other mods to that data structure too for the disassembler.
Okay.
So you're on notice, Jeff.
I'm on notice. I'll pay more attention to it this time. Hey, Chip, I actually went and just grabbed that code without telling you, so it wasn't your fault. I just integrated it without saying anything, and
Yeah, that's
somehow
the
I missed
point
it.
where things are gonna, well, you know,
Yeah.
that's where you get snagged, and I need to tell you, but, all right.
That's great to hear, Jeff. Thanks for the quick locating and recovery of this.
Yeah, you're welcome.
There are a lot of people that have their Christmas hopes hung on a P2 Edge and a Johnny Mac board and some kind of project. All right, shall we go down under? Are they awake?
Yep.
All
yep,
right.
Okay. I'll just share my screen here. Okay, are you guys seeing my Proptool screen?
Yep.
Yep.
Okay. So the idea with this interactive debugger was to make it an object that could be included in with your projects. So you'll probably see here there's an object here that's the debugger. That simply there's a one line. I'll just scroll down. You guys can see that, okay?
Yep.
And there's one line here that just invokes starts the debugger. Basically, the number 7 there is saying I want the debugger to start on cog number 7, and I've just got a baud rate and pins for communicating to the debugger through a serial terminal. And there's a few other little bits of data here which I'll get back to explain what they are. But when you want to actually debug your code, you actually have to launch your code through the debugger so that it instigates all the debug service routines. So there's two different styles. You can launch PASM code and you can launch spin code. In this case, I'm just launching a couple of small little snippets of PASM code. So basically here I'm just saying a cog address, a cog number of 16. So I'm allowing the P2 to allocate a free cog. I'm giving it the name of the code that I want to launch. I'm passing in a parameter, which in this case is 0. And for each cog that you launch, you can actually attach a label to it. The reason for this was because when you're launching these cogs, you may not know which cog number it is that you want to actually debug. So by attaching a label to it, the debugger actually keeps track of all of that. So it's easy to reference it by name. And this is all to do with tying in with the symbols that I bring in, which I'll explain that a little bit later, how that procedure works. But basically, if I just scroll down, we'll just have a look at this first little snippet here. I've just got a basic little loop running. It's just going to turn LED number 16 on, which is I've got the control board set up at the moment. I'll start my camera. I'll see if you guys can actually see the camera going. See, can you guys see that? The LEDs blinking on the board?
Yes.
So it's basically just cycling around. So when you launch any cog, you can tell it whether you want it to be launched in a running state, which is just completely free running. There's no impedance on speed or anything like that. Or you can launch any of your code in a halted state. So it's just sitting there ready for you to single step through. So what I'll do is I'll flick across to my serial terminal. And here we go. So when you jump into the serial terminal, it'll give you some information as to what the cogs are that have actually been launched in debug mode. And you can see that there's statuses there saying that some of these are halted, but one of them is actually running, which is the LED stuff that you can see cycling there. Now, the command prompt that comes up actually tells you what the selected cog is that you're actually going to have access to. So at the moment, I'm on the alpha cog, which is what the LED program is that's running there at the moment. Now, if I actually hit escape here, I'll just widen that screen a bit because it just chopped it off. Let's go a bit wider. I'll do it again. So by hitting escape, what I've actually done is I've halted that actual program, so you can see the LEDs have stopped blinking. This line is actually giving us a status of where we're at the moment. So the first line is it's actually showing us what the current contents of the hardware stack is. Now in this program, we're not doing any calls or anything like that, so that'll just be garbage that's in there. The next line, we've got a whole bunch of information that's related to interrupts and break codes and various things. And if we're single stepping using the bytecode engines and things like that, some of that information will appear there. But the main thing is you'll see that we've got the current flag states, the actual program counter, the actual instruction disassembled, and it's just sitting there waiting for us to do something. Now, I've got some hotkeys in it. If I just hit the plus key, well, we do another step, and I can just keep repeating that. And you can see that each step that we do has incremented the program counter. Now, what we're actually seeing is this is the next instruction that will be executed when I hit the step button.
I have a super quick question. Is there a way of actually checking the like the 0 or the carry flags as well?
There on the left-hand side, you'll see where it says NZ or Z or C, NC. They're actually active the whole time on the side, and you can actually change them at any time while you're stepping through. So, for example, if I was to type set C, that actually has gone in, and that has actually set the C flag, or I could do say set Z. So you can actually force the flags at any time while you're stopped. Technically it can do that while a program's running, but of course there's no actual real use of that. But when you're stopped, yes, you can actually force those flags to be whatever state that you like. Now the lines, the disassembled lines that pop out, it's an intelligent disassembler. So if there's any instructions that are augmented, say with aug-S or aug-D, it'll actually show you multiple lines, because when you do a step, if there's an augmented instruction, it will actually do those 2 instructions, or 3 in some cases, in the one step. You can't actually single step the aug by itself. The other thing is, if you encounter a repeat block, that repeat block will be executed in one step, because you cannot single step a repeat block. So that's the basic single step that happens there. Now, some of this information you may not want to see it all the time, so I do actually have a way that I can hide some of this information. So when I step through, as you can see, I'm stepping through now, just pressing the button, you should see the LEDs changing. And I've got rid of a lot of that data that you don't really need to see. And you can also do things like, let's say I want to step 100 times, and there you go, it's just running through 100 steps, and then it should stop. Yep. Now, as you can see, it's got a disassembler, and if I type disassemble, there we go. Because I didn't enter an address, it just assumed 0. So you can see the code there in its disassembled form. There's some smarts that are attached with the disassembler that it tries to use symbols that I've attached in. But some of the things like constants and things like that, I haven't attached those in because you can get some confusing output, because it doesn't know which constant to use if you've got an immediate value, for example, because in your code you can have multiple constants that have the same value, but they have totally different labels on them. So breaking the symbols into groups is sort of become the tricky part. So at any time I can just type run, and that'll just go back to running at full speed again. And I can switch to another cog, for example. So if I type cogs, we can see that there's some other cogs that are sitting there halted, I can switch to one of those cogs by just simply typing its name. So I'll just switch across to Bravo. And if I do a disassemble now we've got some.
You misspelled Bravo.
Did I?
Yeah.
I'm looking at too many screens at once. Here we go.
Don't you have to say cog Bravo?
You're right. I'm getting ahead of myself. All right. Try again. Okay. That's better. So at any time, you can switch between your cogs by name, or you can actually give it a type by a number if you want. But names I found is a little bit easier because the name might actually be a name of a driver or something along those lines. Now, at any time, even while a cog is running at full speed, I'll start this cog off anyway. And we should have, if I'm looking at the screen right, where are we? It's always the way with demos, isn't it? They don't do what you think it's going to do. Oh, I know why, because I'm on the wrong cog. Okay. We should see a red LED blinking on the second board. Okay. So in this example here, I've got some skip instructions and skip F instructions. So if I stop that and I go back to PC0, now you can change the program counter at any time when you're stopped to whatever address you like. So if you're testing a bit of code and you want to jump to another piece of code and you know the label of it, you can just type in the address and you'll actually change to that address. Okay, I'll just do a step again. Now, because it's just encountered a skip instruction, what it's actually doing is predicting what's actually going to happen. So when we continue on from here, it shows you actually which instructions will be cancelled or treated as not. And so this is sort of giving you a heads up of, we've got this skip. Now when I single step through it, you'll actually see that its predictions. So you can see it's cancelling that instruction. I'll step again. That one's clear, it goes through. That one's clear. This one's cancelled, clear. That one's cancelled, and that one's cancelled. So it gives you a warning, so you can actually see whether or not when you've defined your skip patterns, whether or not you're actually going to get the right combination of instructions. And the next one it'll encounter is the skip F, which its behaviour is different to the skip, as you'll see. So here it's showing this is what's going to happen when it executes the skip F. Now the first instruction is cancelled. Part of the rules of the skip is if the very first instruction is cancelled, it'll execute as a NOP. But you can see the next three instructions. Now this was exactly the same skip pattern as the skip that I showed just before. But you can see the behaviour of the skip F is totally different, is that it's obviously the fast skip. And if you look at the program counters on the left-hand side, you'll see that there's some gaps in the addresses that proves that the skip F is actually going to skip over those addresses. So there's a bit of smarts in the disassembler when you're single stepping through that it'll actually show you if you've got skips, what's actually going to happen. And also if you have a repeat block, so it'll actually show you in the next step, this whole repeat block is what will be executed in one step. Now at any time, for example, if you wanted to look at hub RAM, I'm looking at it here in bytes, or I can look at hub RAM in words, obviously longs. I can look at decimal versions of the bytes, decimal word versions of the bytes. There's some more long versions of the bytes. I can even do, let's see, signed bytes, signed words and signed long, so you get the idea there. I can also look at text. At any time, I could read LUT contents, for example, 102 to say 110. And even things like the special function registers. Now, a lot of this stuff you can actually do while the cog's running at full speed. What it'll actually do is it'll stop the cog, go in, interrogate, get the data that it wants, comes back and then releases the cog and it goes back to full speed again. So it's kind of like a drive-by, I suppose, that it just briefly stops it, gets what it needs and then lets it go.
Hey, Brian,
yeah.
I have a question.
Yeah.
On the skip F, you were just filling in the instructions that got skipped, right?
Yeah.
Instead of just saying it was at this address, then it was at this address, then it was at this address.
Yeah.
I see. I wonder if there's a way though, because that's the same thing that the skip and skip F would wind up looking the same in the debugger then, right?
Yeah, except it'll actually show you all the instructions that will be skipped over when you show a skip. But in the skip F, it just leaves out. You know how in skip, if the instruction's cancelled, this will actually show you that that instruction's been cancelled. When you show the skip F, it just removes all the ones that are never executed. So you just get a clean view, I suppose, of this is what's actually going to be executed.
Oh, so you don't get all those interstitial instructions showing up in the feed?
No, not in skip F.
Oh, good. Okay, yeah, because I was thinking that's how it should be.
Only the scenarios where the instruction is actually cancelled. You know, when you've got that wrap where you have 8 instructions in a row in the skip F, it does I think it's you call it a NOP instruction, or that very first instruction, if it's cancelled, executes as a NOP. So they show up just as the rules are for the skip or skip F. Does that make sense?
That's yep. That's looking really good. You know what Brian's done here, you guys, the documentation in the Silicon covers this. You could use the debug system for a lot more than just debuggers. I mean, well, you kind of need, it's for debugging, but you could build all kinds of things. What he's done here is one way of an infinite way of approaching the problem. You could make your own little debugger stub, which is just a tiny little program that just maybe increments a counter or something. And it doesn't have to do much at all, and you're in and out of there pretty quick. But he's built here like a nice debugger that works over a terminal. There's a lot of stuff you could do with the base debugging hardware. And it's not, once you get into it, the amount of code required to make it play is not much at all. It's kind of like smart pins.
Yeah, the interrupt service routine in the background just has a basic command set of read cogram, write cogram, read, write LUT, and a few other things where it's collecting the relevant data of the program counter, the flag states, and where I'm actually getting the actual stack contents. It's just quite small little routines, but there's just a bunch of them, and they all just talk to the debugger, and the debugger, whenever it launches any of these things, it just puts them all in the debug state. So you can have them all just start in run mode and everything will just run at normal speed, and you can just select which cog you want, break into it and interrogate it. The other thing that I've sort of put into it is that you can access registers straight away. So if I give you an example of that, let's see, where was I? Okay, we're in the right cog. I'll run that again. So we've got the blinking red LED on the right-hand side, and I've got a, and I'll just disassemble it so we can see the code. I'll go a bit further. 0 to 1F. And the right spot is here. So you can see I've got a variable called LED3, which is just being used to indicate what LED is actually being used. If I type the name LED 3, I've got direct access to that register and the program's running. So it broke in, got the value of LED 3, and then it let the program run again. So you can see that the LED is number 31, which is the red one that we've got there. Now I can actually change any register name if the symbol name is known to any value live while the thing's running. So if I was to change that, for example, to LED 24, the point that I just put in front of the 24 indicates that I'm putting in a decimal number, because the default is hex, or you can enter binary numbers if you want. Now, so if I click that, that should have moved. Looking at the camera, yep. So that moved to a different LED. So that was a program that was running, and I just changed one register value, and the program was obviously unaware of what I was doing, and it just changed to that new value. So you can actually interrogate values at any time. The standard ones, you know, say for example like point array, if you just type the name of any value variable, it will go in, get that value and bring it back out. Or if you follow it with a value, you can actually change values live. So that makes it really neat when you're testing code, that if a value is not quite right while you're single stepping through, you can just type in a new value and just tweak it. That's probably one area of the debugging that I think I've probably used the most, is being able to instantly access values and to be able to go in and change them. You can also build in a watch list as well. So if you want to tie certain registers into a watch list while you're stepping, each step you can actually see the new value as you go along. And that there's a whole bunch of stuff that I've got in there that I can turn on and off, that it attaches in on the status of when you're stepping. So obviously you can go too far sometimes and you can have information overload, but if there's key registers that you want to view, you can actually attach them into a watch list, and then as you step through, you can actually look at them in action. So, so that's the basic nuts and bolts of what I'm working on. It's still got a few bugs and things I've got to fix, and documentation is my next big challenge, is putting it all together. But the idea was to try and attach, or being able to attach a debugger to your code in the minimal amount of lines. And you can see there's not a lot of lines there into launching it off. And this little inline ASM snippet at the front here, what I'm doing is just stealing the P-base and V-base values from Spin, because I need that to, when I'm accessing any hub addresses, I need to know those offsets, because the symbol data that I'm using that's generated by Peanut offsets, and I need that base address so that I can calculate the right addresses. So that's the only little trick that's going on there. And yeah, any questions?
Yeah, actually, I have the where you get the symbol from Peanut, you get the symbol table, because I'm kind of confused that you have the labels accessible inside of the.
Yeah, that's the trick. At the moment, the only way I can generate symbols is using Peanut. So this code that we've got in front of me here now, I actually have to compile that in Peanut and do a Control-L, which generates that symbol table. Then I have some other Spin code, which I run, which extracts the symbol data that I need and sort of compresses it down into a format that's more user-friendly for my debugger. And what it actually does is it stores it up in higher hub RAM, just below the top 16K. And I actually start from the top there, and I store it down. It grows downward. Then so it's sort of a three-step procedure. I actually have to compile the code in Peanut to generate those symbols. Then I run it through another bit of Spin code, which extracts that data and parks it up in the top of hub RAM. And then I fire off the code you see in front of you, and then it goes and it looks and it sees those symbols and it picks up on them. And if I scroll down to the bottom here, sorry, up the top here, when I launch the debugger, you'll see that I've got here a label that says at my batch. Well, that's actually a batch file. If I scroll further down the screen here, this is the batch file. So I've got some commands that run when I first launched it off. I've got things like VT100, which puts it into a terminal mode that uses the control codes for VT100, or there's PST for PST cursor control codes. And then basically all I'm doing here is I've got some commands which get symbol, and I'm just bringing in the various symbols that I need. What happens is when you do a get symbol command, depending on what cog you've actually selected, it attaches those symbols to that cog. That way, when you switch in between the different cogs, you get the relevant symbols that you need for that cog. Because quite often you've got your cog code all have similar addresses starting at cog 0. So it's quite possible that you can have multiple labels that are all of the same value. So for the disassembler, it would get really confused as, well, which label do I use? Because there's a few that match for that address. So this way is a way that I sort of split off the symbols for their specific cog. And that way, when I'm disassembling or single stepping through, I get the relevant labels for that cog. So need to think a little bit more, I think, on, I was thinking of writing a tool that generated all this sort of stuff. That's sort of the final step. Maybe this might be something that might be able to incorporate it into Proptool or something, maybe with talks with Chip and Jeff.
Yeah, that's what I was thinking of as you were talking about it.
Yeah. So this sort of stuff might be able to be integrated in. Because initially I thought using the file command, I could just bring in the symbols into this file here and that should be okay. But what happens is you need those symbols to be, it's the chicken and egg, what comes first, you know. You can't attach the symbols in afterward, because then it messes up all your pointers. Everything shifts when you put in that data. So yeah, we might have to come up with a technique, I think, and a format as well that suits everyone, that we can attach in this stuff and make it optional, maybe a button in preferences or something like that, that if you want symbols attached in, or we might need to. It's one of these things that I didn't know what I was doing until I sort of got 90% down the road, and then I realized, oh gee, I should have done this or I should have done that. You're sort of making it up as you go along. There wasn't a real plan at the start. This is
so hard to figure at the outset. You couldn't do it. It wouldn't be practical for implementation. The only way I can get anywhere is to start moving, and then it kind of it appears where I have to go, you know. But I wouldn't have known that if I start moving.
Yeah, yeah.
And you know, we could do something, because as you were speaking, I was thinking, what if we could just have like a file or something where the compiler inserts its symbol database at that point?
Yeah.
But then I wasn't thinking that you had already considered it, that this presents a sizing problem that throws everything off. But
yeah,
what we could do, though, is we could get around that by saying maximum this size and fit as many, you know, whole records in there as that space will permit. So you don't get any clipped records, you get whole records, and then you can adjust the size of that as you need. But that way, it doesn't present a problem to the compiler about, you know, during different passes having different sizes occurring.
Yeah. Yeah. And one other idea I had was that whenever you have an org statement, perhaps you could have an optional string on that line, which is actually the cog name or cog label. And then any labels that follow, a little bit like with your procedure with labels with a dot that ties them into a label that's a non-dot label. A similar thing, that if you've got a cog name, any labels following that org statement will automatically get tied to that cog. So that way, when you import the symbols or attach to them, they're already grouped off that you're not using a label that's actually attached to the wrong cog. But these are the things I sort of discovered along the way when I was a fair way down the track.
Yeah, I haven't gotten to that point of thinking. I mean, I've had a lot of thoughts about how to do this symbolic debugging, but it's not going to come together until I actually do it. And then I'll be able to slay the dragons as they appear. Right now, it's just too hypothetical.
Yeah.
I started last night working on, because I'm working on something similar, but it will be in the context of the debug displays. And I realized last night, my problem, the big thing I have to do, the big busy work ahead of me is the disassembler, which I see you've been working on. And there's a lot to do with the disassembler, like even how do you search based on the instruction code? I mean, I'm using a table, kind of like would you call it a binary tree that has masks and match values. And you navigate the tree because there's all kinds of funny things that different instructions present. I mean, you might have one instruction that like pop A could also be like a read long with a pointer, but you have to be able to recognize that, oh, this is a subcase of that general instruction, which I'm sure you've already dealt with.
Yeah. I've pretty much done the same thing. I've got masks and I've got some what I call rule bits, and each bit represents certain things, that whether there's Z and C flags attached, or whether immediates are allowed on D or S. And so I've got a few bits that work as the rules, so it knows what things it prints out. But having all that data actually works as an advantage the other way as well, that I have actually got a one-line assembler as well. Because you've already got all those rules and the labels, you can actually type in a line and actually assemble a direct line of code if you want into a spot. But that was just a freebie that came because you've already got all that data. And rules there. You could reverse it very easily.
Well, it's great to see you guys sharing resources. Maybe you can save us all some time too. And putting that in Proptool.